Here is the first question. In this question, there are given a mixture of formic acid and oxalic acid. It is treated with H2SO4, and the evolved gases are treated with the KOH. Weight of the remaining product at STP will be they're asking. So very interesting question. In this question, what is the function of H2SO4? It is a dehydrating agent. Remove the water molecule from the substance, and KOH is the substance which will be remove the carbon dioxide. These two functions are there. For KOH, remove the CO2, and H2SO4 remove the water molecules. Okay, so if you observe that here formic acid, if it is after elimination of water, it will be give the carbon monoxide. It is the equation 1 you can take, and H2C2O4 it will be give the carbon monoxide and carbon dioxide. Okay, so as they given some information, by using that we are finding number of moles. As we know, 1 mole of formic acid give the 1 mole of carbon monoxide. So 2.3 grams means it is a mass by molar mass. We are using 0.05 moles we are getting, so it will give 0.05 mole of CO. Same way, H2C2O4 it is a 0.05 moles. It will be give 0.05 moles of carbon monoxide, 0.05 moles of carbon dioxide. And in this gases, only carbon dioxide was absorbed by the KOH pellets from the K2C and from the K2CO3. Okay, so remaining here you will get 0.05 mole of CO from formic acid and 0.05 mole of CO from H2C2O4. So total we are getting number of moles of carbon 0.1 mole, that is weight is equal to number of moles into molecular weight. As we know that molecular weight of carbon monoxide is 20, so 0.1 mole means 2.8 grams. So this 2.8 grams will be remain at the final product. Thank you. In question number 2, they given the hydrated salt Na2CO3.XS2O undergoes 63% loss in water on heating, become anhydrous. We have to find the value of X. Okay, they given options 10, 12, 8 and 18. So by using this information, we can able to find the what is the value of X. How to find? First, they given anhydrous salt, so it loses water molecules on heating, so that we know that. And the mass percentage of water is given 63%. Generally, the molecular form weight of the compound will be 106 plus 18x will be there. So this 18x weight will be have the mass 63%. Then remaining 106 will be have 37%. So by cross multiplying this one, we can get 18x into 37 equal to 63 into 106. By solving that, we will get the value X is equal to 10. So the formula is Na2CO3.10H2. Or we can use another way to find the value of X, that is percentage of water equal to mass of water by molar mass into 100. So percentage of water is given 63, and so mass of water here is 18x and molar mass 106.18x into 100. So by solving this, we will get the value X, that is 10. Thank you. Question number 3 we are going. Suppose two elements X and Y combine to form two compounds XY2 and X2Y3 when 0.05 mole of XY2 weighs 5 grams while 3.011 into 10 power 23 molecules of X2Y3 weighs 85 grams. The atomic mass of X and Y respectively. So here to find atomic mass of X and Y. So in order to find the atomic mass, we have to know that the molecular weights of XY2 and X2Y3. Generally, we know the formulas. Number of moles is equal to mass by molar mass, number of particles by Avogadro number, volume by molar volume at STP. So by using these formulas, we can able to find this question. We can solve these questions. So molecular weight equal to mass by number of moles. So first compound XY2 case, they given 0.05 mole of XY2 weighs 5 grams. So mass 5 grams, moles 0.05. So molecular weight is equal to 5a 0.05, that equal to 100. So x plus 2y is equal to 100. So this is the first one. And in second case, x2y3 3.011 into 10 power 23 molecules of x2y3 weighs 85 grams. So first we are finding number of moles, that is coming 0.5 mole, and molecular weight 85 by 0.5, that is 170. So here 2x plus 3y equal to 170 will become. Okay, so we have x plus 2y equal to 100 and 2x plus 3y is equal to 170. So by solving this 1 and 2, we can able to find the atomic weights of x and y. It is coming 40 and 30 respectively. Thank you. In question number 4, in an organic compound of molar mass 108 gram per mole, it has carbon, hydrogen, nitrogen atoms are present in 9:1:3.5 by weight. We have to find the molecular formula of the compound. So they given 4 options. We have to find which option is correct. So here they given carbon, hydrogen, nitrogen atoms are present in the 9:1:3.5 by weight ratio. So we are taking carbon, hydrogen, nitrogen. So moles we are finding, this we are considering directly as a mass. So they given by weight, so that's why we are directly considering by mass. So carbon 9 grams and hydrogen 1 gram and nitrogen 3.5 grams present. So moles we can find mass by atomic mass for elements. So 9 by 12 for carbon equal to 0.75. Hydrogen case 1 by 1, that is 1.00. Nitrogen case 3.5 by 14, so that's 0.25. So next we have to find relative number of moles. How to find relative number of moles? We have to check that which number of moles is a small one. By using the smallest number of moles, we have to divide all the moles with that smallest number of moles. So here 0.25 we are dividing with all number of moles. 0.75 by 0.253, 1 by 0.254, 0.25 by 0.251. So we will get the simplest ratio of atom. Okay, so C, H and N ratio will become 3:4:1. Empirical formula will be C3H4N. Empirical formula weight will becomes 54. Already molecular weight is given 108 gram per mole. And how to find molecular formula? Molecular formula equal to empirical formula into x. X we can find molecular weight by empirical formula weight. So molecular weight we already know 108. Empirical formula weight 54. So by using that we are getting x value 2. So substituting here, so we'll get the molecular formula 18 and N2. So C6H8N2. So which option is correct? So option 1 is the correct option. Thank you. In question number 5, 1.44 grams of titanium, atomic weight 4.48, reacted with excess of oxygen and produce x grams of non-stoichiometric compound, titanium 1.44, oxygen 1.0. The value of x we have to find out. So here titanium reacting with the oxygen and forming one non-stoichiometric compound. So if you know that equation, titanium reacting with oxygen, excess of oxygen giving this non-stoichiometric compound. So 1.44 mole of titanium react with the excess of oxygen, it is forming the 1 mole of this titanium, 1.44 oxygen 1.0. So from that 1.44 moles means it will be like 69.12 grams of titanium is reacting with it is giving the 85.12 grams of this non-stoichiometric compound. Now in question they given 1.44 grams of titanium reacting. So if 1.44 grams of titanium reacting, how much you will get the compound? So by cross multiplying you will get x value 1.77 grams. So option 2 will be the correct one. Thank you. Question number 6. Calculate the final volume of reaction mixture when 10 liter CO and 10 liter O2 are allowed to react to maximum possible extent provide that all the measurements of volume are made under similar conditions of pressure and temperature. So options given 15 liter, 20 liter, 25 liter and 10 liter. So this question is related to limiting reagent concept. So how to handle the questions related to that, we will go through it one. First, basically you have to write the balanced equation. Here carbon monoxide is reacting with oxygen and for it is undergoing combustion, means it will be give carbon dioxide. So balanced reaction you can write CO plus half of O2 giving rise to CO2. So from the equation you can get it at similar conditions of pressure and temperature. 1 liter react with half liter of oxygen and give the 1 liter of carbon dioxide. What is the data given for us? 10 liter of carbon monoxide, 10 liter of oxygen is given. Now which one is the limiting reagent? First you have to find out that. In this case 1 liter react with a 0.5 liter. So 10 liters react with a 5 liters, but we have 10 liter, means excess of oxygen is there, extra 5 liters will be there. So this is oxygen is a excessive reagent and CO is a limiting reagent. So how much? Always a limiting reagent completely react, and according to limiting reagent only product formation will be takes place. So here 10 liter limiting reagent is there, that will be completely reacted. In this 10 liter reacted with a 5 liter oxygen and 1 liter give 1 liter, so here 10 liter give 10 liter. So finally we have 5 liter of oxygen and 10 liter of CO2 will be produced. Here we can get limiting reagent CO and excessive reagent oxygen. How much moles of how many liters of oxygen left unreacted? 5 liters. Here number of moles of CO2 formed 10 liters. So final volume of reaction mixture is 15 liters. So they can ask any questions like find limiting reagent, excessive reagent, how much excessive reagent left unreacted, how much product formed, maybe in terms of moles, in terms of molecules, like this final volume of reaction mixture. So we can handle like these questions here related to limiting reagent concept. Question number 7. A 3.4 grams of sample of H2O2 solution containing X percentage H2O2 by mass required X ml of a KMnO4 solution for complete oxidation under acidic condition. The molarity of KMnO4 solution is 1 and 2, 0.4 and 0.2. So in this case we are taking 3.4 grams of H2O2, but it is not 100% pure, it is a X percentage pure. So that is a one point, and it is reacted with a KMnO4. It is oxidation reaction generally. Number of gram equivalents of H2O2 reacted equal to number of gram equivalents of KMnO4. Okay. So here H2O2 related they given mass, so we are using weight by equivalent formula, and this side they given number of gram equivalents, we want to find molarity, so we are using N into V in terms of ml by 1000 we are using, and it is weight is equal to 3.4 grams, but it is not 100% pure, so X percentage pure, so we are using X by 100 here, and equivalent weight of H2O2 is 17 because molecular weight 34 and valency factor 2, and for acidic medium KMnO4 valency factor 5, so normality is equal 5 into m, so molarity into valency factor into how much volume is using X ml, so X we are using, so by 1000, so this X and it will be get cancelled, and molarity if you find you will get the 0.4 mole per liter. Thank you.